Hello and welcome. Our topic for the day is adding radical expressions, includes variables and requires some factoring. To understand the concept, let's do some questions. Before we start off, let's understand the concept of adding radical expressions. Just as with regular numbers, radical expressions can be added. But we might not be able to simplify the addition all the way down to a single number. To add radical terms together, they have to have the same radical part. This is the most important thing to be observed and to be taken care of. Let's understand this concept with the help of the questions given. The first one says simplify, and we're given 7 radical 9e squared minus 12eu plus 4u squared plus 2 9e squared minus 12eu plus 4u squared. Now if you notice carefully that inside the radical we have the same expression. So 7 plus 2 becomes 9, and here we have 9e squared minus 12eu plus 4u squared. Now if we observe, we can factorize the expression inside the radical. We'll use by the method of splitting the middle term. So this can be written as 9 square root of 9e squared. Factors of 36 can be written as negative 6eu minus 6eu. This is the negative 6eu plus 4u squared. So we have 9 outside. From the first two terms you can pull out a 3e. Inside you are left with 3e minus 2u. From the last two terms you can pull out a negative 2u, and inside we are left with 3e minus 2u. This is equals to 9. Inside the radical we put the factors together, 3e minus 2u times 3e minus 2u. Now these can be paired and they come out as a single term, that is 9 times 3e minus 2u. Finally, using the distributive law, we get 9 times 3e as 27e minus 9 times 2 is 18u. This is our final answer. Can be seen in option C. Let's try the next question. It says simplify 3p z squared radical 8p squared z cubed plus pz radical 8p squared z5. Now here we see inside the radical the terms are not similar, so we'll factorize 3p z squared. 8 can be written as 2 times 2 times 2, p squared as it is. Z cubed can be written as z squared times z plus pz. 8 can be written as 2 times 2 times 2, p squared as it is. Z to the power of 5 can be written as z squared times z squared times z. So now we'll make groups inside and see what can be pulled out. 2 2's come out as a single 2 multiplied p squared as a single p, z squared as a single z, and inside we are left with 2 and a z, that is these two terms, plus p z. Here we can pull out a 2, p squared as a p, z squared as another z, and another z squared as another z. Inside we are left with 1 2 and 1 z. We'll multiply the terms outside the radical. We have 6 p squared z cubed. Inside we are left with 2z plus we have 2 p squared z cubed. Inside we have 2z. So here we see we have similar radical parts, we can add them. So this makes it 6p squared z cubed plus 2p squared z cubed in parentheses multiplied by square root of 2z. Now this is 6 plus 2 8, because they are like terms can be added. This is 8 p squared z cubed square root of 2z. This is our final answer, can be seen in option A. Let's do the next question. Simplify and we given negative 3p squared square root of 48 w5 p4 plus 5p squared 12 w5 p4. Again we see that both the terms are not similar, so we can factor. 48 can be factored as 2 times 2 times 2 times 2 times 3. w5 can be written as w squared times w squared times w times p4 can be written as p squared times p squared plus 5p squared. Inside the radical we have 2 times 2 times 3, then w squared times w squared times w, and p4 can be written as p squared times p squared. All this expression is under the radical sign. So we have negative 3p squared. Now we'll make groups of 2, 2 2's, this is 1 and this is another pair, so this comes out as a single and another single 2, then w squared as 1w, another w squared as another w, this will remain, 3 will remain inside, p squared as a single p outside, and another p squared as another p. Inside we are left with 3w plus we have, let's write it here, 5p squared, 1 2 from here, we get a w from here, another w from the second w squared, and 2 p's from the 2p squared, and inside we are left with 3w, that is this 3 and 1 w. So now we'll multiply the terms outside the radical. We have negative 3 times 2 is 6, multiplied by another 2 we have a negative 12. We have w squared p to the power of 4 plus, multiplied by square root of 3w plus 5 times 2 is 10 w squared and p4 square root of 3w. Now we see we have the same radical inside over here, so we arrange it like this, plus 10 w squared p4 all multiplied by square root of 3w. Now these two are again like terms, w squared p4 w squared p4, so negative 12 plus 10 is a negative 2 w squared p4 square root of 3w. This is our final answer and can be seen in option A. I hope adding radical expressions including variable requires some factoring is easy now. Thank you for watching and have a nice day.